Where is my pen?
So, what we're looking at today, technically it's called proving triangle similarity. We're really not, I took off the only full proof on homework, so we're really not writing full proofs like what we've seen in the past. What are you doing? You're just being weird. What are you doing? We're not writing full proofs like we have in the past. We're talking about how we could prove, or more, probably the better title would be showing triangle similarity by AA, or angle. So that's what we are looking at today. It's pretty quick. So here's, I think this is the only slide of notes, and we have some examples. And it's theorem 8.3. It's the angle-angle similarity theorem. It says if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. Which, hopefully, when we think about it for half a second, that totally makes sense. Like you can see in the image. These two angles are congruent. Let's say they're, 70 degrees. Right. You guys are probably writing that down. These two are congruent. This is congruent. Then these third angles have to be congruent as well. Notice that they're saying that the two triangles are similar, so the angles are all congruent because the angles are all the same, right? The angles have all the same measures, 70 degrees, 30 degrees, 80 degrees. But the triangles, like triangle ABC and DEF, are similar, right? Remember, we talked about similar triangles or a similar transformation means that we're changing in size. We talked about a dilation. We had that slide with the big dilated eye. So the triangles are similar, but the angles are congruent. You guys get what I'm saying with that?
Oh yeah.
Oh yeah. Sweet. So that's the only thing we're looking at today. If they give us some type of image or story problem or whatever it might be, and we can show that the two triangles have just two congruent sides, without a doubt, for sure, then that's enough to say that the two triangles are similar. So example 1, determine whether the triangles are similar. If they are, write a similarity statement, which we've done in the past, and then explain your reasoning. So, what do you guys think? Are these two triangles similar? First, let's start there. Are these two triangles similar? Yes?
Yeah.
No?
What's 64 plus?
The real question is, what
We don't know.
what is angle E?
We don't know.
So can we find angle E?
Yes.
64?
It's not.
Oh, is you find
So determine if they're similar? Yes, they're similar. When it says write a similarity statement, that would just be matching up our angles, saying this angle is congruent to this angle. So somebody give me two angles that are congruent to each other.
D and G.
Angle D is congruent to angle G. Someone give me another one.
C.
C. Okay, last one.
GD.
Nope, we already got that.
Oh.
EH. H. So that would be right here. If it says write a similarity statement, that is this right here. We've done in the past. We haven't done it very many times because I understand doing them, but I also think that it's kind of redundant. You don't want to write 12 similarity statements. And then explain our reasoning. Well, we would give a quick explanation, like all the angles have a corresponding angle that's the same, or something along those lines. Your explanation could be a lot of different things. Questions on that? explanation should include something with the angle theorem, because that's what we're talking about today. Angle similarity theorem. Technically, to say that these two triangles were similar, you only had to talk about two of the angles, but in the similarity statement, we had to list all the angles that were congruent. Another example. Show that the two triangles are similar. So to show that they're similar, we just need to show that two of the angles are congruent. Let's start with letter A. What angles, right off the bat, if we have the smaller triangle and the larger triangle? I heard somebody say EC. I blocked all the letters so that would help. Angle B is congruent to angle C. We know that for sure. They tell us that. What other angle or angles can we say are congruent with those two triangles?
E and D.
E and D? Well, we don't. They could be, but we don't know that for sure.
A.
Well, I thought we already had two angles.
Because they're angles, because A's, well, they're all things.
Yeah, angle A.
Oh, I already thought we had angle.
And this is where I would expect you to cite with property. What? What property? Angle A is congruent to angle A. It's congruent to itself.
Reciprocal.
No. No. Reflexive. Good.
Oh, yeah.
There's not an S in there.
Super cool.
Not reciprocal. So, show that the triangles are congruent. Well, we can state that these two are congruent to each other because they tell us that. Now, if, like when we are assuming A is congruent to A, we do have to cite how we know that, or give some explanation, cite the theorem or whatever. I mean, it's pretty obvious that A is congruent to A, but we also have to kind of prove it. I guess that's where the proving part comes in, is citing the theorem. Then to wrap it all up, we would say that triangle ABE, triangle ACD by the AA similarity theorems. All right? Angle similarity theorem, again, says that if we can show that two angles are congruent, then we have similar triangles. Letter B. What is one angle that we know for sure is congruent?
E.
There is no E in letter B.
V.
Oh, V. Angle S, V, R is congruent to U, V, T. By what property?
Vertex. Vertical.
Vertical. What else? Notice that these are parallel lines. That should hint us into something way back to chapter 3.
S and U.
What?
S and U.
S
A
and
goes
U.
S
Why?
Because those lines are parallel,
Yes.
and they are
Alternate what? S, V here, U, V here. Alternate interior. Very good. Just like in the past, when they give you parallel lines, that's a big hint that you'll be using alternate interior angles. Again, we're talking about, no, don't die. How long has that been up there?
It just popped
Oh,
up.
okay.
5 minutes.
5 minutes.
Hey, we're actually, can you leave this example up so I can like know what I'm doing? Like,
Yeah. It'd also probably be good to have it down in your notes so that on the test you can use it. So I would say to probably take notes. But I can leave it up so you can copy it down in your notes too. Now, what's the last thing I need on letter B to finish this problem and kind of get the proof part involved? What do I need to state? What do I need to say? Yeah, triangle SVR is similar to UVT because of the angle, similarity theorem. Questions? You guys good? Well, Jeff? All right, last example. This is a real life example for you that you could use like today.
Totally.
A flagpole casts a shadow that is 50 feet long. At the same time, the woman standing nearby, who is 5 feet 4 inches tall, casts a shadow that is 40 inches long. Notice this is in feet, this is in inches. How tall is the flagpole to the nearest foot? So, luckily, with this one, they give us the picture drawn already, because that would be kind of annoying to have to draw on your own. So if we are solving this, I guess I'm going to draw my own now.
I want to do something.
If we are solving this, what's probably the first thing we should do? What would be helpful? Yeah, so we have 5 feet 4 inches. So how many inches would that be?
64.
64. All right, Jack. How many inches is 50 feet? Good. Now, what proportion would we want to set up?
Do 5 feet 4 inches.
No, we just convert everything to inches. We don't want to go back to feet.
Well, just put
I'll
the
take-
foot on that.
What do we think? What proportion would we want to set up?
600 over 40 is equal to x over 64.
600 over 40, so we keep that consistent. So this is equal to x over 64. Who's got the calculator? Someone, get a calculator. Cross multiplying.
Cross multiply. Go.
Probably.
6 times 6.
All right. Wow.
It's 36.
Divided by 40.
160.
960 inches. So divided by 12. 80 feet. 80 foot high flagpole. Is that believable?
That makes
Definitely.
sense.
Does it make sense?
Yeah. Because the woman is taller than her shadow.
Yeah.
Because the woman is taller than her shadow.
How many feet? How many feet did you say? 80 feet. I like it.
She's a big lady.
Yeah.
Look at that.
You bet have a bigger.
That's an 80 foot flagpole, that's not a 5 foot pole.
Oh yeah, she is, isn't she? She's in the
She's like 10 foot.
Yeah, she's about, what is each story, 10 feet? Yeah, she's like 12. Small.
Yeah.
Hey, but it says it's not drawn to scale. Also, that flagpole is way bigger than the building.
Yeah.
But the building's probably set back. That's probably right. I'm not sure why they would put the building there. It doesn't really make sense. Now, one last thing, then I'll get you guys a worksheet. The reason, like, this problem seems more like what we did yesterday, right? But the reason that we're looking at it today is because the only reason we're allowed to set up this proportion is because they tell us that these two triangles are congruent with these two angles, right? Since we have two angles that are congruent, that means we have made similar triangles right here, so that lets us set up the proportion. Right, guys? That's why we're allowed to set up our proportion, because we know these two triangles are similar from the angle theorem that we talked about today. That's it. That's all we got. So